Today's lesson is about pace. Pace is the reverse of speed. And by reverse, I mean mathematically, it is the reciprocal of speed. So where speed is distance over time, pace tells you the time per certain amount of distance. So for instance, you could see here on my Apple Watch, it was telling me my average pace. My pace was 10 minutes and 14 seconds per kilometer. So time, the 10 minutes, the distance, 1 kilometer. So mathematically, you're going to write out the formula for pace as pace equals time over distance. And again, just like with speed, there's lots of different units that you can use. Technically, the default would be seconds per meter, but in practice, it's usually based on kilometers or miles. It's very rarely based on just the single meter. Okay, you'll notice here, oftentimes if you do a long distance run or bike or skate, you will get splits, which tells you your pace for each kilometer or for each mile or each lap, however they're going to do it. So you have to be careful how it works. But regardless of how they do it, you'll notice that with pace, bigger numbers mean slower. So it's different than it was with speed. Here, smaller numbers mean you're going faster. The reason it's backwards is because pace is the reciprocal. So as speed gets bigger, the pace gets smaller. Here are some practice problems to try. The first one involves Tori Canuck as she runs from home plate to first base. So the first thing we need to know is the distance, and it tells you the distance right here. Then we need to know the time. We look at when she left home plate. We look at the time she crossed first base, and we subtract them to get the change in time. We then use our formula. So when you're doing this, make sure you write out for your work the formula in words with no numbers. Then write it out again, but this time put numbers in place of the words so someone can follow along easily with what you did. Finally, give your answer and make sure you tag on the units. Our distance was in meters and our time was in seconds. So our unit at the end would be meters per second. Here you're going to do one with Andrew running a 3,200 meter race, but we are going to focus only on the first lap, the first 400 meters. So you have the time and the distance. Make sure you write out your formulas. So for speed, it's easy. You're going to do the distance on top and the time on the bottom. When you're doing pace, you're going to do just the opposite, but be careful of your units. We want our pace in minutes, not seconds, and we want our distance in kilometers, not meters. So when we do this, make sure you do a conversion to turn seconds into minutes and 400 meters into kilometers. Remember, 1,000 meters make a kilometer and 60 seconds make 1 minute. Okay, again, show all your work. Formula without numbers, the numbers that you plug in, your answer, and your units. Finally, I'd like you to do a unique problem where you're going to use a stopwatch to time a car, and the car will travel 400 meters, and I'm going to ask you to find both the car's speed and the car's pace. The speed will be in meters per second, just like Andrew, and the pace will be in minutes per kilometer. So be careful.